Let's solve problem 7.1 for Microelectronic Circuits 8th edition by Sedra and Smith. For the MOS amplifier, we have a VDD equals 3 volts, threshold voltage of 0.5 volts, Kn of 10 milliamps per volt squared, and RD equals 15 kiloohms. And yet to determine the coordinates of the active region segment, so A to B, of the voltage transfer curve, which is this curve here that I've included. So coordinate A is pretty easy. It's just the threshold voltage in the x-axis or the VGS axis. So that's 0.5 volts. And then the y-axis is just, for VDS, it's VDD. So 3 volts. So let me get those values out. So we have 0.5 volts, 3 volts. Okay. Now B is a little more complicated, so let's focus on VDS at B. So we can calculate that with this chunker of an equation. It's 2 times Kn times Rd times VDD plus 1, all under a square root, minus 1 divided by Kn times Rd. So let's evaluate that. So VDS at B is equal to the square root of 2 times 10 milliamps per volt squared times the resistor, 15 kiloohms. Note that milliamps is 10 to the power of negative 3, and kiloohm is 10 to the power of 3, so those powers will cancel out. VDD is 3 volts plus 1, all that under a square root, minus 1, all of that divided by 10 times 15. So I calculate VDS at B to be equal to 0.193 volts. And lastly, VGS at B is simply equal to the threshold voltage plus VDS at B. So that means VGS at B is just equal to 0.5 volts plus 0.193 volts, which is equal to 0.693 volts. So that means our coordinates for B, VGS will be 0.693 volts, and VDS will be 0.193 volts. And that answers the question. Thank you for watching my video. For any questions, comments, or video suggestions, feel free to reach me in the comments section or by email. Thank you and have a great day.